Hello everybody, welcome into another lesson. So today we are going to talk more about ellipses, this time where the center is not at the origin. So here we have two forms of an equation. First form is where the x-axis is still the major axis for the ellipse. So that means that the ellipse is more elongated on the x-axis than the y-axis. You have a formula of the general form x minus h, that quantity squared over a squared, plus y minus k squared over b squared equals 1. Again, the right side of the equation should always equal 1. And the a squared denotes that the x is the major axis. Well, to find the center of the ellipse, you just set the x minus h equal to 0, you'll get the x coordinate at h, and then set y minus k equal to 0, you'll get the y coordinate of k. So your center is at the point hk. And then to find your vertices, just take the square root of a squared, and then since the x-axis is the major axis, you'll take x both plus and minus a, and then you'll leave your k alone for your y. And then you have your co-vertices, in which you have your y-axis as your minor axis. So this time you leave your x value of k alone. You'll take that, you'll leave your x value of h alone. Then you'll take k plus or minus b. And then, of course, to find the foci, c squared still equals a squared minus b squared. If your x-axis is your major axis, you'll take h plus or minus c for your x coordinate, then leave your y coordinate of k alone. So that's if the x-axis is the major axis. Now let's transition to when the y-axis is the major axis. All right. So we have a situation here where this time the y-axis is the major axis, so the ellipse is more elongated on the y-axis than the x-axis. So if the y-axis is the major axis, that means then the formula is going to be x minus h squared over b squared, which would denote that x-axis is the minor axis this time, plus y minus k squared over a squared still equals 1 on the right-hand side. The center hasn't changed, it's still hk, but your vertex, if y is the major axis, this time you'll have your x coordinate at h, but you'll take that plus and minus a, you'll add it to k. So your vertex will be at both h, then k plus and minus a, to denote that the y-axis is the major axis. Now for the co-vertices, that deals with your minor axis. This time the x-axis is the minor axis. So your co-vertices would be h plus and minus b, then k. And then for the focus, still c squared equals a squared minus b squared, but if the y-axis is the major axis, you'll leave your x-coordinate of h alone, and then you'll take k plus and minus c for the coordinates of your foci. So those are the general forms of the formula for for an ellipse where the center. That's just the general form for the equations of an ellipse, but this time we're dealing with the center not at the origin. So let's get into some examples here. All right. So let's see. We have x minus 1 squared over 9 plus y minus 3 squared all over 25 equals 1. Alright, so x minus 1 squared over 9 plus y minus 3 squared over 25 equals 1. Alright, so which number's bigger? Definitely 25, and it's below the y term, so that means the y-axis is the major axis this time. So the y-axis is the major axis. Alright, now let's find the center. So set the x minus 1 equal to 0, you get the x-coordinate of the center at 1. Then set y minus 3 equal to 0, you get y equals 3. So the center is located at 1, 3. So let's plot the center. There's your center at 1, 3, right there. Now, to find your vertices, you're going to, then we know since the y-axis is the major axis, so that means a squared equals 25, which means a equals both plus and minus 5. So your vertices, the y-axis is the major axis, so for the vertices you have your x-coordinate of 1 doesn't change, but let's take 3 minus 5, you would get negative 2 for the y-coordinate, and then if you take, you'll keep your x-coordinate of 1. If you take 3 plus 5, you'll also get a y-coordinate of 8. So your vertices are at 1, negative 2, and 1, 8. So let's go ahead and plot that. So there is 1, negative 2, and then we have 1, 8 right here. Alright, then we need to find the co-vertices. Well, that indicates then we're talking about the minor axis, the y-axis. So we know b squared then equals 9, which means b equals plus and minus 3. So to find the co-vertices, this time we're affecting the x-coordinate since it's the minor axis. So take 1 minus 3, you'll get negative 2. Leave your y-coordinate of 3 alone. And then also take the x-coordinate of 1 plus 3, you'll get the 0.43. Those will both be your co-vertices. So here is negative 2, 3. And then we need 4, 3 right here. So those are your co-vertices. At this point we have enough to draw the ellipse, so let's go ahead and do that. So there's the ellipse itself, and then we need to find the foci. So still c squared equals a squared minus b squared, which in this case is going to be 25 minus 9, which would equal 16. So that means c equals both plus and minus 4. Now the y-axis is the major axis, so what does that mean? That means we're going to leave our x-coordinate of 1 alone for the center, but we'll take 3 minus 4, which would be negative 1, so 1 negative 1's a focus. And then you'll also have 1 for your x-coordinate, and then 3 plus 4 is 7. So your foci are at 1, negative 1, which is right here. So there's 1, negative 1, and then you have 1, 7, which is right here. So there is the graph of the ellipse with center at 1, 3, with the y-axis being the major axis, and then your various foci. Alright, I got more examples here. All right. Let's see. So we have x minus 6 squared all over 4. Actually, no, let's change that a bit, because this will put us off the charts. What if I took x plus 2 squared all over 4 plus y minus 4 squared all over 1, set that equal to 1. So I have x plus 2 squared all over 4 plus y minus 4 squared all over 1 equals 1. Well, which number is bigger? Definitely the 4, right? And that's below the x term, so this time that means the x-axis is the major axis. So we have the major axis is located on the x-axis. Now, let's find the center. So to get the x-coordinate, set that x plus 2 equal to 0, you'll get the x-coordinate is negative 2. To get your y-coordinate, set y minus 4 equal to 0, you get the y-coordinate of 4. So the center is located at negative 2, 4. So there's your center at negative 2, 4. Now, next thing, though, let's see. Since the x-axis is the major axis, that 4, so a squared equals 4, that would have to mean that a equals both plus and minus 2. And since the x-axis is the major axis, to find your vertices, you got to take then that center and add and subtract 2 from negative 2 to get those coordinates. So if I take negative 2 minus 2, I would get a vertex at negative 4, 4. Then if I add 2 to negative 2, I'd also get a vertex at 0, 4. Those would be my vertices. So here's negative 4, 4. And then we also have 0, 4. That's another vertex. And then let's deal with the minor axis, which is the y-axis. So b squared equals 1, which means b equals both plus and minus 1. So to find my co-vertices, that's going to end up being then, I'll take the y-coordinate of my center, and then first let's subtract 1. So leave the x-coordinate of negative 2 alone. 4 minus 1 is 3, so I have a co-vertex at negative 2, 3. Then if I take 4 plus 1, I'll have another co-vertex at negative 2, 5. So let's see, negative 2, 3 right here. Then I'll have negative 2, 5 up here. Now I at least have sufficient points to draw this ellipse. So there's my ellipse with the center of negative 2, 4 with my various vertices. But I do need to find the foci. So take c squared equals a squared minus b squared. Well, that's going to then mean that that would equal 4 minus 1, which c squared equals 3, so that means c would equal both plus and minus the square root of 3. And if the x-axis is the major axis, then my foci are going to be found at the coordinates negative 2 plus and minus the square root of 3, and then my y-coordinate of 4 stays the same. So let's figure this out here, where I can plot my foci. So let's see, negative 2 minus 3 would equal negative 2 plus the... No, that's not right. Hold on. Negative square root of 3 minus 2. Alright, so about negative 3.734. So there's a focus. Pretty close to a vertex. And then we need to take negative 2 plus the square root of 3. That'd be about negative 0.27, so that's going to put me about right here for the other focus. So there is the graph of this ellipse with the various foci and vertices, with the center at negative 2, 4. Alright, so as you see, so far this still isn't too bad, even though the center is not at the origin. Now let's change this up a little bit. What if you were given this equation? So you have 9x squared plus 4y squared plus 36x minus 24y, dang it, I forgot the x on the 36, plus 36x minus 24y plus 36 equals 0. So how are you going to approach something like that? This is the equation of an ellipse, but it's not factored, and your right side does not equal 1. So 9x squared plus 4y squared plus 36x minus 24y plus 36 equals 0. Whenever you're given this, here's what you got to do. So group your x terms together. So you'll have 9x squared plus 36x plus 4y squared minus 24y, and then I would get rid of that constant on the left hand side, so subtract 36 from both sides, you would get negative 36 on the right hand side. Okay, now you got your variable terms together, so 9x squared plus 36x plus 4y squared minus 24y equals negative 36. Now, on your x terms, factor those. Factor out the constant only. Don't factor out the variable with it. You would end up with 9 times x squared plus 4x. And then do the same with your y. Factor out only the constant. Plus 4 times y squared minus 6y equals negative 36. There's a reason for this, okay? Now, what you want to do is complete the square on each of these variables. So keep the 9 outside of your parentheses, alright? So what is, if we complete the square of x squared plus 4x, alright, so 4 divided by 2 is 2, 2 squared is 4. So you end up having 9 times x squared plus 4x plus 4, plus now keep that 4 outside of the parentheses in your y, so complete the square on the y terms. You'll have y squared minus 6y. Now, what is half of negative 6? That's negative 3. If you square negative 3, you get plus 9. That's going to equal negative 36 on the right-hand side. But remember, when you complete the square, you have to add it to both sides. Well, you're not just going to add 4. you're really going to add 9 times 4. What is 9 times 4? That's 36. So you'll add 36 to the right side, plus you're not just going to add 9 from the y, you're going to add 4 times 9, which is also another 36. So make sure you distribute the multiples from outside the parentheses when you're doing this completing the square stuff on the equations. So this should turn into 9 times the quantity of x plus 2 squared plus 4 times the quantity of y minus 3 squared would equal 36. Now one more thing. The right-hand side equals 36. It should equal 1, right? So divide both sides by 36. You'll end up getting x plus 2 squared all over 4 plus then y minus 3 squared all over 9 equals 1. Now you have the equation of an ellipse. That's why we went through the process of getting the variables together, factoring out the constant terms, and then completing the square. So we can get the equation of an ellipse. Now we know what we're working with here. So it's plain to see the y-axis is the major axis. So a squared equals 9, meaning that a equals plus and minus 3. Now what's the center? The center, of course, would be at -2, +3. So here is -2, +3. There's your center. Now, to get your vertices, since the y-axis is the major axis, you're going to take that center of -2, 3. So first let's subtract 3 from the y. You'll get a vertex at -2, 0. Then you add 3, you'll get another vertex at -2, 6. So here's -2, 0. You'll get another one at -2, 6. Alright. Now let's find your co-vertices. Well, that means b squared equals 4. So that means b equals both plus and minus 2. So your co-vertices are going to be, since the x-axis is your minor axis, take that -2 and subtract 2. You'll get a co-vertex at -4, 3. Then take your x-coordinate of -2 and add 2. You'll get another co-vertex at 0, 3. So here is -4, 3. And then you have 0, 3 right here for the other co-vertex. Now we have enough to graph this ellipse. Didn't quite want to bring the hook over that way. That's too far out. So there's the shape of the ellipse. Now let's find the foci. So c squared equals a squared minus b squared. Well, that would be 9 minus 4, which would equal 5. So c equals plus and minus the square root of 5. So my foci, I know I'm running out of room. My foci, since the y-axis is the major axis, would be at the points, let's see, -2, then 3, plus and minus the square root of 5. Those are my foci at -2, 3, plus and minus the square root of 5. So let's go ahead and figure out what this is. So that would be about -0.24 for my y coordinate. So -2 Did I get that? Did I read that right? Nope, I put in the... That'd be about 0.76. So here is my first focus. And then let's see, if I take the square root of 5 and add 3 to that, I'll end up getting about 5.24, which would be about right here. So there's my second focus. So there we go. There's the graph of this ellipse where we started out with this mess and got it down to something much simpler with the center at negative 2, 3 and those vertices. All right. Now, all right, what if we had let's do, let's see, 9x squared. I'm going to move this over here. So we have 9x squared plus 4y squared minus 36x plus 8y plus 31 equals 0. Alright, so 9x squared plus 4y squared minus 36x plus 8y plus 31 equals 0. Well, once again here I'm going to say let's get our variables together. So that's going to turn into 9x squared minus 36x plus 4y squared plus 8y. Now, we want to get rid of that constant term of 31 on the left, so this is all going to equal negative 31. So 9x squared minus 36x plus 4y squared plus 8y equals negative 31. Then now we got the variables together, so factor out the constant, or the coefficient on your variables. So this would end up becoming 9 times x squared minus 4x plus 4 times y squared plus 2y equals negative 31. All right. At this point, then, we want to complete the square with our variables. So leave 9 outside of the parentheses here. So complete the square on x squared minus 4x. So x squared minus 4x plus 4 is what that would be. Plus 4 times your y squared plus 2y plus 1 is going to equal then negative 31 you already have, plus you'll take 9 times 4, that would be 36, plus 4 times 1, which would be 4. So this would turn into 9 times x minus 2 squared plus 4 times y plus 1 squared equals 9. Alright, so you have 9 times the quantity of x minus 2 squared plus 4 times the quantity of y plus 1 squared equals 9. We almost got something we can work with, but the right hand side needs to equal 1. So divide both sides by 9. You'll end up with x minus 2 squared plus 4 times y plus 1 squared over 9 equals 1. We're almost there, but here's the thing. Look at your second term. The coefficient of your second term in the numerator is not 1, it's 4. How are we going to equalize this out so we get a coefficient of 1 in our numerator? In order to do that, you have to divide both numerator and denominator by 4. So if I take the numerator and divide it by 4, I get 1. If I take the 9 and divide it by 4, that would give me 9 times 1/4, which would give me 9/4. So really, then this is going to turn into x minus 2 squared plus y plus 1 squared all over 9/4 would equal 1. So I've just divided both numerator and denominator by 4. So yes, we actually can have fractional denominators. You will have that sometimes. Well, 9/4 is definitely bigger than 1, right? So that means, once again, y is your major axis. Let's go ahead and erase this, because I think we get the idea of what we just did here, okay? So, y is your major axis. We can establish that. Now, having said that, what is the center? The center, of course, would end up being x minus 2 equals 0, so you have 2. And then y plus 1 equals 0, so y would equal -1. So your center is going to be at 2, -1. Alright, so there's your center. Now, we've determined that the y-axis is your major axis. So a squared equals 9/4. So that means a equals plus and minus 3/2. The y-axis is your major axis, so take a -1 minus 3/2 to find your first vertex. Leave your x-coordinate alone, you'll have 2. Alright, -1 minus 3/2, that would be -5/2. And then you also leave your x-coordinate of 2 alone. Now take -1 plus 3/2, you'll have 2 1/2 for your other vertex. So 2 -5/2 is here. And then 2 1/2 is here. Alright, so we found our vertex. That means the x-axis is your minor axis. So b squared equals 1. Alright, so that means b equals both plus and minus 1. So to find your co-vertices, you'll take your x-coordinate of the center of 2. Let's subtract 1. You'll get a co-vertex of 1 -1. And then take 2 plus 1, you'll also get another co-vertex at 3 -1. So here's 1 -1. And then you also have 3 -1. At this point, we can draw the shape of this ellipse. So there's a very small ellipse right there with the center at 2 -1. Now, the last thing we got to do, I'm going to keep this original equation here because I think we see the process now of how we got to where we were. Alright, so we need to find the foci. So again, c squared equals a squared minus b squared, which means then that 9/4 minus 1 is what c squared equals. So this means that c squared equals 5/4, which then means that c equals both plus and minus the square root of 5 over 2. Yeah, that just got a bit messy, didn't it? But you can have that. Well, if the y-axis is the major axis, that means then that you'll leave your x-coordinate alone. You'll have 2, then -1 plus and minus the square root of 5 over 2 for your foci. Now let's figure out where I'm plotting these exactly. That'd be about -2.12. So there's my first foci right here. My first focus. Now let's see where my second focus is going to be. Be about 0.12, which would also be about right here. So there's my foci, and then there is the graph of my ellipse right here. All right. So I think we get that. Now, like in the last exercise, we're going to do some characteristics here. We're going to be given some characteristics of an ellipse, and we got to find the equation. So let's see what characteristics we're given. So we have vertices at the points -1, 2, as well as 5, 2. Then we have co-vertices that can be found at 2, 0, 2, 4. Alright, so we have vertices at -1, 2, and 5, 2, co-vertices at 2, 0, 2, 4. Alright, so that's all we know are the vertices and co-vertices. We don't know the center, we don't know any axis lengths yet, or anything like that. Well, here's a trick if you're just given vertices and co-vertices. So we can use the distance formula to find the center, right? Because the center is always equidistant between the two vertices or between the two co-vertices. Basically, if you have a set of each, pick one. I think the co-vertices are going to be easier to work with, right? So the center of 2, 0 and 2, 4, well, that's going to end up being x-coordinate of 2, y-coordinate of 2. So your center is actually at 2, 2, right? So that's going to help us. Now, if my center is at 2, 2, and my vertices are labeled for x-coordinates, that means my x-axis is my major axis. So let's start there. We know the center is at 2, 2. So this is going to be x minus 2 squared over some number plus y minus 2 squared over some number equals 1, right? So my major axis, notice from 2, 2 to negative 1, 2, that's a change of 3 units. And then from 2, 2 to 5, 2, that's another change of 3 units. So that would have to mean that my a equals 3, so a squared would have to equal 9, right? And if my x-axis is my major axis, my 9 would go below my x minus 2. And then now let's look at my co-vertices. From 2, 2 to 2, 0, that's a change of 2 units. From 2, 2 to 2, 4, that's also another 2 units. So that means my b would equal 2 units, so b squared would equal 4. So y is my minor axis, so the 4 would go below the y minus 2. So the equation I should get is x minus 2 squared over 9 plus y minus 2 squared over 4 equals 1. Those would be that'd be the exact equation we're looking for. Alright, I have vertices at 4 plus and minus 4. Then I have co-vertices at the points 1, 0, and then again at 7, 0. Alright, so I have 2 vertices at 4 and then plus and minus 4, and then co-vertices at 1, 0, 7, 0. Alright, so let's find the center. So the center, of course, halfway between 4, negative 4 and then 4, positive 4 would be 4, 0, right? That would be 4, 0. I could do the same with my co-vertices. Halfway between 1, 0 and 7, 0 is also 4, 0. So my center is 4, 0. That would just save you from putting in the distance formula. That would just kind of help you out. Now, we know the center is 4, 0, so that's going to look like, for the start of the equation, x minus 4 squared over some number plus, well, y minus 0 squared, which in this case is just plus y squared, would equal 1 on the right-hand side. Now, which axis is your major axis? It actually would appear that the y-axis is your major axis, because you have 4, negative 4, and then 4, 4, which is a distance of 8. You have your co-vertices from 1, 0 to 7, 0, which is only a distance of 6. So the x-axis is definitely your major axis. Alright. Well, if the center is at 4, 0, that means from 4, 0 to 4, negative 4, that's a distance of 4. From 4, 0 to 4, 4, it's another distance of 4. So that means a equals 4, which then means that a squared equals 16. So my 16 would go below my x minus 4, since that's my major axis. No, I'm sorry, it would go below my y, excuse me. Wishful thinking. Pardon me, it would go below my y, since the y-axis is the major axis. So my co-vertices, 1, 0, 7, 0, they're each 3 units distance from the center. So my minor axis would be length 3, so b equals 3, so b squared equals 9. So what you should get then is x minus 4 squared over 9 plus y squared over 16 is equal to 1. All right. Now this one, different. Vertices are at 0, 2. Four, 2. So vertices are at 0, 2, 4, 2. Minor axis, length 2. Alright, so all we're given are the vertices and the length of the minor axis. Well, let's look at what changes in your vertices here, right? You have 0, 2, and 4, 2, so the only change is for your x. That means the x-axis is your major axis. So the x-axis is major. That would have to mean your y-axis is minor. So what's the center then if x-axis is major? Halfway between 0, 2, and 4, 2, that would be 2, 2, right? So my center would end up being at 2, 2. Makes life a lot easier. Now, we already determined the x-axis is the major axis. So you have a distance of 2 units each between your two vertices, so that means my a equals 2, so a squared would equal 4. And we determine x is major, so that means this is going to be some form of x minus 2 squared all over 4 for my a squared plus y minus 2 squared over some number equals 1, right? Okay. Now it says my whole minor axis is length 2. We know y is the minor axis. That means from the start, from one end of the y-axis to the other end that the ellipse contains. If you're just given a whole axis length, what that's really talking about is that 2b equals 2. That means the whole length of the axis. So to find b, you're going to take half of 2b. Half of 2b equals 1, so b equals 1, which means b squared equals 1. So what you should get for your equation would end up being x minus 2 squared all over 4 plus y minus 2 squared over 1 equals 1. So that's actually not too bad either. Alright. Now this changes again here. What if we have, so they give you two foci to start with. The foci are at 0, 0 and 4, 0. So the foci are at 0, 0 and 4, 0. Major axis length 8. So we have the foci are at 0, 0 and 4, 0. Major axis length 8. Alright. Well, what's true about the foci? That the center is halfway between the foci, right? So halfway between 0, 0 and 4, 0 would be 2, 0, right? So the center would have to be at the point 2, 0. Easy enough. Now, we know we can start with then x minus 2 squared over some number plus y squared over some number equals 1. This is where we have a bit of a puzzle on our hands. It says the major axis is length 8. So that's from one end of the x-axis to the other which is our major axis, the whole axis is length 8. So that means 2b equals 8, so b would equal 4. Major axis, that's a, pardon me, good grief. 2a equals 8, so a would equal 4, which means a squared equals 16. And since x is our major axis, so that 16 would go over x minus 2 squared. Now, we know the length of the foci. The center is between them, right? Notice it's a 2-unit change from the center in each direction. So that means c equals 2, which means c squared equals 4. What's the formula then? We need to solve for b squared since we don't know that yet. That's okay. Remember, c squared equals a squared minus b squared, which means we're going to set 4 equal to that a squared of 16 minus b squared, which means b squared would equal 16 minus 4, which means b squared equals 12. So you'll put that underneath the y squared, so the equation you should get would be x minus 2 squared over 16 plus y squared all over 12 equals 1. And I got more. All right. Foci are at 0, 0, and then again at 0, 8. So we have foci at 0, 0, 0, 8. Major axis, length 16. Alright, so foci at 0, 0, 0, 8, major axis length 16. Well, what is true for the foci? That the center is halfway between them, right? Halfway between 0, 0 and 0, 8 is 0, 4. So the center would be at the point 0, 4. So to start with, you'll then end up having x squared over some number plus y minus 4 squared over some number equals 1. Okay, so there's that to start with. Major axis equals 16, which means then that 2a equals 16. That's the whole length of the axis. That means a equals 8. So that could only mean a squared equals 64. Okay. Well, notice the foci are on the y-axis, which means then, and the foci only deal with the major axis. So that means your major axis is actually your y-axis. So that 64 is going to go below the y minus 4. Now we need to find the length of the minor axis for the x-axis. Well, so the center is 0, 4. Between 0, 0 to 0, 4, that's a 4-unit change. Between 0, 4 to 0, 8, that's a 4-unit change. So that means that c has a length of 4, so c squared would have to be 16, right? Well, we can solve for b squared by setting c squared equal to a squared minus b squared. So 16 equals 64 minus b squared, which would have to mean then that b squared equals 64 minus 16. So b squared would equal 48. So that would go below your x squared. So the equation you should get would end up being x minus 2 squared over 48 plus y minus 4 squared over 64 equals 1. All right. Let's see here. Do a couple more. Let's do a couple more. So this time they give you the center at 2, -1. So that's easy. They gave you the center. They give you one vertex at the point 2, is that, what is that? 1/2, okay. 2 1/2. They give you one more piece of information. Minor axis length 2. Alright, so we have the center of this ellipse at 2 -1, vertex at 2 1/2, minor axis length 2. Well, let's start with the center. This is going to take the form then of x minus 2 squared over some number plus y plus 1 squared over some number equals 1. Right? Okay, so let's take a look here at this then. If you have a vertex with the same x-coordinate, but you have a change in the y-coordinate, that means your major axis is actually the y-axis. So let's start there. Y-axis is major since we have a change in the y-axis then. So that is where the major axis is. Now, between -1 to 1/2, how much is that, right? That would be for our A. Well, here's the thing. What's -1 in terms of half? Well, that's -2 halves, right? If I add 3 halves, I get 1/2. So that means my A would have to be 3 halves, right? So A squared would end up having to equal 9/4. And y-axis is my major axis, so this would be over 9/4 for your denominator of y plus 1 squared. All right. Here's another piece. Minor axis is length 2. That's talking about the x-axis. So the whole minor length axis is 2. So that's 2b equals 2. That means that b equals 1, so b squared equals 1. So we just found it then. We found our equation. The equation we should get is x minus 2 squared over 1 plus y plus 1 squared over 9/4 equals 1. All right. I think I have like 3 more. Yep. So let's see. Vertices located at 3, 1 and again at 3, 9. So those are two vertices. And then they give you that the minor axis has length 6. Minor axis length 6. Alright. So vertices at 3, 1 and 3, 9. Minor axis length 6. Alright. Well, what's true for the vertices? That the center is halfway between the vertices, right? So what point is halfway between 3, 1 and 3, 9? That's definitely going to be 3, 5, right? The center is going to be located at the point 3, 5. So this equation is going to take the form of x minus 3 squared over some number plus y minus 5 squared over some number equals 1. Now let's figure out what those some numbers are. Well, if they're vertices and there's a change in the y coordinates, that means that the y-axis is the major axis. So the y-axis is actually your major axis. Now, from 3, 5 to 3, 1, that's a change of 4 units. From 3, 5 to 3, 9, that's also a change of 4 units. So that means my a equals 4, so a squared equals 16. And since my y-axis is my major axis, my 16 goes below my y minus 5 squared. Now, the minor axis has a length of 6. That means the whole minor axis. So that really means 2b. So from co-vertice to co-vertice, the whole length is 6. So 2b equals 6. That means b equals 3, so b squared equals 9. So that 9 will go below the x minus 3 squared. Should give us the equation then x minus 3 squared over 9 plus y minus 5 squared over 16 equals 1. Alright, two more. It's going to change on us yet again. Alright. We have a center at 3, 2. Now here's where it gets interesting. A equals 3c. Your foci, well, that's not right. Foci are at 1, 2, 5, 2. All right, we got it now. So, center is at 3, 2. A equals 3c, foci are at 1, 2, 5, 2. Well, that center at 3, 2 jibes with the fact that it's halfway between your foci. So to start with, let's set this up here for the equation. If the center's 3, 2, that means this is going to be x minus 3 squared over some number plus y minus 2 squared over some number equals 1. That's to start with. Now, alright, so A equals 3c. Now here's the thing. So your foci, the center's halfway between them. So from 3, 2 to 1, 2, that's a change of 2. And then from 3, 2 to 5, 2, that's also a change of 2. So that means my c itself would have to equal 2 units. So c squared equals 4. That c squared is going to come into play in just a minute. Now they tell you a equals 3c. So a equals 3 times 2, which then means that a equals 6. So a squared would have to equal 36, right? Now, foci denote your major axis. There's changes in the x-coordinate. That means the x-axis is your major axis. So that a squared of 36 would go below the x minus 3 squared. Now what we don't know yet is the length of your minor axis. But what we do know is that c squared equals a squared minus b squared. So c squared is 4. That equals 36 minus b squared, which would have to mean that b squared equals 36 minus 4. So b squared equals 32. So that 32 would go below your y minus 2 squared. And you should end up getting the equation x minus 3 squared over 36 plus y minus 2 squared all over 32 equals 1. And one more, then we're done. We'll be done after this. All right. Good one. Vertices are at 5, 0 and 5, 12. Wait, I didn't want to do that. That one's too easy. That's like what we were doing before in the beginning. I wanted to do a slightly harder one, actually. The center is at 0, 4. What else are we given? A equals 2c. Your vertices are at negative 4, 4. And then positive 4, 4. Okay. So center of the ellipse is at 0, 4. A equals 2c, and then the vertices are negative 4, 4 and 4, 4. Okay. Let's start out with your center. Well, this would take the form of x squared over some number plus that y minus 4 squared over some number equals 1, right? That's the start of it. Now, the vertex always denotes your major axis. So from that center of 0, 4 to negative 4, 4, that's a change of 4 units. From 0, 4 to 4, 4, it's also a change of 4 units. So that means A equals 4. So then my A squared would equal 16. And we've determined that the x-axis is the major axis, so that 16 is going to go below the x squared. Now, if A equals 2c, here's the thing, we got to solve for c. A equals 2c, which means that c equals A over 2, which would have to be 4 over 2, which would have to be 2. So c equals 2. Well, what do you know? That means c squared equals 4. We just solved for c. We don't know the length of the minor axis. That's about to change because c squared equals a squared minus b squared. So that means 4 equals 16 minus b squared. So b squared equals 16 minus 4, which equals 12. So that 12 is going to go below the y minus 4 squared. Final equation you should get is x squared over 16 plus y minus 4 squared over 12 equals 1. Alright, so that's it for ellipses. On the very next lesson, we're going to start a 2-lesson series on hyperbolas, which are the final type of conic section we'll talk about. So, I hope everyone has a great night. Take care.